The new chapter which we're going to deal for today's session is linear equations in two variables. What is a linear equation in two variables? Let's recap with the polynomials. We have discussed about the different types of polynomials, initially with linear polynomial, quadratic polynomial, cubic polynomial, quartic and quintic, etc. So proceeding the similar manner, we are now going to deal with linear equations which are very much connected with the linear polynomial. And since I have two variables, the condition is that the polynomial needs to essentially have the two variables x and y, of course. So let's see in brief about the linear equation and its two variables and its respective definition. Before we go into the definition, let's get into introduction on linear equation to recap with the linear polynomial. As we know that the polynomial function denoted by p of x with variable x is linear if it has its highest degree of the variable as 1. Say for example, I have this to be ax plus b. In this case, I find that the highest degree of x is 1 and hence such a polynomial is called a linear polynomial in x. In the variable x. So clearly seeing this linear polynomial, I find only one variable which is x and its power being 1. Therefore, the degree of this entire polynomial is 1. And such a polynomial with degree equal to 1 is called a linear polynomial in the variable x. Now let me connect with what could be the linear polynomial in two variables x and y. So to connect with the linear polynomial in two variables x and y. Let's see how we can define the respective definition of linear polynomial in two variables x and y. So let's reconsider the definition which says that a polynomial is linear if its variable is with power 1. The highest power is 1. Therefore, when I introduce the two variables x and y into the polynomial, then I clearly assume that I need to have both the variables with degree 1. So a linear polynomial in two variables x and y, unlike the one variable x, is defined to be ax plus by plus c, because each of the term has degree 1 with variable x here being degree 1 and this term equally having the degree as 1. Therefore, such a polynomial is called a linear polynomial in two variables. Here, this is a linear polynomial in one variable x, but because I have the introduction of two variables x and y, this is a linear polynomial in x and y. The two variables here being x and y. A linear polynomial in x and y defined to be p of x comma y equals ax plus by plus c, provided the condition a, b, c belong to real numbers. The three constants or the coefficients must be real numbers, and the rule 2 being a and b should not be equal to 0. They must be non-zero. A, B, C belong to R and A and B are non-zero real numbers is how I define the linear equation, linear polynomial in two variables x and y. Any example we can take for this would be, say for example, I have pxy is 2x minus 3y plus 4, then this is clearly with the first term being with degree 1, and coming to the second term, its degree also being 1, and of course the degree being 0. The highest degree for x and y is 1, and therefore this is a linear polynomial in x and y. Is how we define the linear polynomial. Now let's take an example problem where we do not have a linear polynomial. The contradictory to this example is what we are going to discuss continued. For example, I have p of xy is 4x minus 3x y square plus 4y minus 3. Let's see if this is a linear polynomial in x and y with xy. So let me just consider this example to investigate for whether this polynomial is a linear polynomial in x and y. So let's take the given example problem in which I clearly have my pxy to be 4x minus 3xy plus 4y minus 3. Now before I justify for its linearity in the polynomial, I have to search for the degree of each of the term. So coming to the first term, I have my degree of x, which is 1, of course, because x power 1. I have my degree of x, which is 1, and I have my degree of y, which is 1. Therefore, on the whole, I find this combined degree of the second term to be 1 plus 1, which is equal to 2. And next, I have my third term whose degree is 1, and I have, because its power is 1 for y, and then the constant term whose degree is 0 because there is no x or y attached. So x power 0 or y power 0 is what we assume. Therefore, I have, for the first term, I have this, and for the second term, I have 2 because the combined degree is 1 plus 1 for each of x and y, and then the overall degree for the second term is 2, and for the third term it is 1, and for the fourth term it is 0. Therefore, when I compare each of the degrees 1, 2, 1 and 0, I identify that the second term, which has degree 2, is not equal to 1. Now, because the degree is not equal to 1, the highest degree for the second term is 2, it cannot be a linear polynomial. For linear polynomial, degree must be equal to 1. The highest degree of the entire polynomial must be equal to 1. Degree 2 not equal to 1. Therefore, the given polynomial is not a condition, is how we understand the concept. So this is a linear polynomial in x and y, and this is not a linear polynomial in x and y. Now that we have discussed about linear polynomial, let's enter into discussing about a linear equation in the same two variables x and y. Linear equation in two variables x and y. Definition. So as we come across, let's recap with the linear polynomial, which is defined to be a polynomial p of x comma y is said to be a linear polynomial in two variables x and y if this is equal to ax plus by plus c, provided all the constants a, b, c belong to R and a not equal to 0 and b not equal to 0. Is how we define a polynomial with a, b, c belonging to real numbers and a not equal to 0 and b not equal to 0. So let's see how we can define the linear equation derived from the linear polynomial. So this polynomial p of x comma y equals ax plus by plus c is called a linear polynomial in two variables x and y if a, b, c belong to R and a not equal to 0, b not equal to 0. Now what is an equation? When does a polynomial become an equation? Is the biggest question in comparison. So as we see here, the linear equation is obtained when I equate the given polynomial to 0. So when I want to convert this into an equation, I just take this in the form equal to 0. That implies a linear equation in x and y is defined to be p of x comma y equal to 0, which is indirectly ax plus by plus c equal to 0. Therefore, a linear equation in x and y is finally concluded to be ax plus by plus c equal to 0, with a, b, c belonging to real numbers, as with the same condition as that for the linear polynomial. So a, b, c must belong to real number, and the second condition being that a and b should be non-zero real numbers, and a not equal to 0 and b is also not equal to 0 is how I define the linear equation in two variables x and y. Linear equation in two variables x and y. Ax plus by plus c equal to 0. A, b, c belong to R, and a not equal to 0, b not equal to 0 is how I define. For example, I take an equation in the form 2x plus 5y minus 3 equal to 0, then let's test whether this is a linear equation in two variables x and y. So initially I test with rule 1. The rule 1 is first to take with the given equation in the form equal to 0. Rule 1 is the degree is 1, and rule 2 is the degree is 1 because its power is 1 for each x and y. So first term the degree is 1, for second term the degree is 1, and for the third term the degree is 0. So the highest degree out here is one. Therefore, that is the rule 1 through which we identify it is highest degree in 1. And number of variables in this polynomial is x and y. Therefore, I have two variables being x and y. Therefore, the number of variables is 2, is the rule 2 which I identify in the given problem. The rule 3 is that the left hand side of the polynomial is equated or can be equated to 0. So left hand side is equated to 0. Therefore, on these three conditions, I can say that the given problem is a linear equation in two variables x and y. If I have these three conditions satisfied, therefore, the given equation (2x plus 5y minus 3 equal to 0) is a linear equation in two variables x and y, is how I understand the given example problem. Any problem given out there to be identified for linear equation in the number of variables, we first take the rule 1 in deciding the highest degree of each of the terms. Finding the degree of each term, we extract the highest degree. If the highest degree of the entire given expression is equal to 1, then it is linear. and here the highest degree is 1. Therefore, this given expression is a linear polynomial. Next is about finding the number of variables in the polynomial. Clearly, we identify the number of variables in the entire polynomial. The variables here being x and y, therefore the number of variables is 2, x and y. Therefore, I can now assume that this is a linear polynomial in two variables x and y, is how we justify. Thirdly, about identifying for the equation. Imagine that if I can write the expression in the form equal to 0, then I can say that the given expression being expressed as equal to 0 makes me clearly confirm that the given equation is a linear polynomial, a linear equation in two variables x and y. A polynomial converts to an equation if it is equated to 0. Therefore, the given equation 2x plus 5y minus 3 equal to 0 is a linear equation in two variables x and y, is how I conclude the given example problem. Now let's take an example problem where the given expression is not equated to 0 and justify if that is a linear equation in two variables x and y. So let's take an example problem to understand the concept more stronger. For example, I have an equation which says 2x minus 5y plus 4 equals 3 minus 9x plus 2y. Now this expression clearly makes me witness that this is not equal to 0. So do I call this a linear equation or do I call this an equation? Let's see how we can justify. Before we do this example problem, one thing is for sure that we need to justify only after the complete solving. Bring it into the most simplified form and then justify for a linear equation in two variables x and y. So let's take this example problem, investigate it. The given problem is 2x minus 5y plus 4 equals 3 minus 9x plus 2y is what is the given expression. So let me try to simplify this by taking all the terms to the left. As I can see that this can be further simplified by taking each of the terms on the right hand side to the left hand side. So 2x minus 5y plus 4 plus 3, when I bring it to the left, it is minus 3 minus 9x when brought to the left is 9x plus 2y to the left is minus 2y equals 0. So I have all the terms on the right which are brought to the left, equating to 0. Linear equation is always equated to 0. Now let's simplify where my 2x and 9x are added to give 11x. And minus 5y and minus 2y are added to give minus 7y because minus 5 minus 2 is minus 7. Then the constants here are added to get 4 minus 3, which is 1, equal to 0. So this is now the most simplified equation of the given problem. So let's see if this is a linear equation in two variables x and y, to be followed with the three rules. Rule 1, the degree of first term is 1, the degree of the second term is also 1, the degree of this is 0, therefore my rule 1 is highest degree out of all these is 1, therefore it's linear. Next, the rule 2, identifying the number of variables. I clearly see that there are two variables x and y. So I have two variables x and y and it is a linear, and as I see that the left hand side is equal to 0, that's the rule 3, my LHS is equal to 0, therefore it's an equation. And overall, I conclude that this is a linear equation in two variables x and y. Indirectly, the given problem, though is not expressed with 0 on the right hand side, needs to be more simplified until it reaches to the complete simplified form and then equated to 0, and thus justifying for the given example problem to be a linear or not a linear equation. This example problem, 2x minus 5y plus 4 equal to 3 minus 9x plus 2y, is a linear equation in two variables x and y. Its simplified form, its most simplified form being 11x minus 7y plus 1 equal to 0. Linear equation in two variables x and y. Now that we have discussed about linear equation in two variables x and y, let's now investigate on the solution of the linear equations. What could be the possible solutions for the given linear equation is what is the next investigation process in the coming topic. So let's see. Solution of linear equation. Of course, here dealing with the two variables x and y is what is the topic of the session. Solutions, as we know, are the values which satisfy the given equation, in this case being linear equation. So let's see what are the values which satisfy this equation in brief. So before we come to the understanding of the concept more stronger, let's investigate through various example problems. For example, I take 2x minus 6 equal to 0. I clearly see this to be degree 1 and degree 0. Therefore, this is a linear equation, but the number of variables is x. So, this being an equation, this is an example of a linear equation in x, in one variable x. So let's recap with the linear equation in one variable and then try to understand the solutions of a linear equation with two variables x and y. So with the example problem which involves a linear equation in x, say for example 2x minus 6 equal to 0, let's see what are its solutions and how these solutions help us in understanding the solutions of the linear equation in two variables. As we can see clearly, the given equation is 2x minus 6 equals 0. Its solution is about nothing but the value of x which satisfies this equation. So let's see what value of x satisfies this equation. Clearly, when you want to identify the value of x which satisfies the equation, it's nothing but about simplifying this equation to get x. Therefore, in order to find x, I take all the x terms to the left and all the non-x terms to the right. So minus 6 does not have x, so it comes to the right as 6 plus 6. Then I have my x, which is 6 over 2, 6 by 2, because 2 comes down here. And then on further simplification, I get this to be 3. Therefore, x equal to 3 is said to be the solution of the given linear equation. Is how we understand the solution. Therefore, x is equal to 3 is the solution of the linear equation in one variable x, that is 2x minus 6 equal to 0, is how I conclude. So how do we justify this in two variables x and y? For a linear equation in one variable, we can find the solution through the simple process by just evaluating the value of x, and that value of x acts as the solution of the given linear equation. But what about a linear equation in two variables x and y. So let's investigate a linear equation in two variables x and y with its solutions. So let's take an example problem of a linear equation in two variables x and y. For example, I have 2x minus 4y minus 7 equals 0. And this is clearly a linear equation in two variables because I have the variables with first term being 1 and the second term degree being 1 and this being 0. Therefore, the highest degree is 1. And clearly with two variables x and y, this is an example of a linear equation in x and y. So this is a linear equation in x and y. So let's see how we can find the solutions for this x and y. As we take here 2x minus 4y minus 7 equal to 0, let's see if we can find the value of x and y which satisfy this equation. Unlike the previous example which we have taken in the previous session, which is a linear equation in one variable x, and let's compare the solutions of the two equations. Now, as we know here, clearly I can find the value of x by taking the constant to the right and then taking 2 down, and then I get this to be the solution. Let's see if I can use the same process for my linear equation in two variables x and y. So proceeding similarly, I get this to be taking the constant to the right as I've taken 6 to the right on the second equation. Taking minus 7 to the right, I get 7, and then let's see if we can find x and y. But again, I have the variable y, which cannot be evaluated when you have the variable x. So here I clearly understand that when I have an equation in one variable, it is easy to simplify and get the solution. But when I have two variables x and y, it is not possible to find the solution x and y for this equation. Therefore, let's see how we can find the solutions of this equation in a more simplified manner. Linear equation in two variables x and y cannot be solved as we can solve for linear equation in one variable x. Can be solved, cannot be solved. So let's see what are the terms or the limitations in solving a linear equation in two variables x and y, unlike the linear equation in one variable x, which can be solved by simple mathematical process. Now let's take an example problem to understand why it is not easy to solve the solutions of a linear equation in two variables x and y, unlike for a one variable x. So here comes the example in which I would like to solve the equation x minus y equals 1. This is clearly a linear equation in one variable, in two variables x and y. When one brought to the left, it can be equated to 0. Therefore, let's see how we can solve this. Now, before we solve, it is very important to note that solving is about finding the variables. Solving is about finding x and y in this case. So we need to know what exactly x and y stand for. So in order that we need to solve this equation x minus y equal to 1, the condition is to find x and y which are real numbers. That is, we are searching for the real numbers which satisfy this equation. To find x and y which belong to real numbers is what is the target. So let's see how this target can be achieved. In order to find x and y from the equation, unlike the general mathematical process, let me try with trial and error method. Let me try with the hit and trial method. So in this hit and trial method, I first take x equals 2 and y equals 1. and let's see if this satisfies the equation. Clearly my left hand side, which satisfies x equal to 2 and y equal to 1, is equal to 1, and which satisfies. Therefore one set of solutions is x equal to 2 and y equal to 1. Let's try another hit and trial method to find the other possible solutions for this. Let me take x equals 3 and y equals 2, and let's see if this satisfies the given equation. My x equals 3 and y equal 2 implies my left hand side, which is 3 minus 2, x replaced with 3 and y replaced with 2. And we know that 3 minus 2 is 1. Therefore, even this set, because it satisfies the given equation, is said to be the solution set for the given equation. Let's try with another example. X equals 9 and x equals 8, and let's see if this is the set of solution. Substituting for x as 9 and y for 8, 9 minus 8, which is 1. Therefore, this also satisfies the given linear equation. So as you can see, there are many solutions. Like even if I take a very random number like 9,999 and I take y as 998, also equally when I replace, I get the solutions as 999 minus 998, which is equal to 1. And therefore, I get the possible solutions for x and y being 999 and 998. It continues and continues, but there is no end to the solutions for this equation. So what does we learn out of this example problem? When we see the example problem x minus y equal to 1, as we see the different sets of solutions for x and y, the different sets of solutions for x and y, all satisfying the given equation, they are all the solutions. This is a solution for the given equation. This is also a solution for the equation. This is also a solution, and this is also a solution for the linear equation x minus y equal to 1 in two variables x and y. So what do we understand? For a linear equation in two variables x and y, there are infinitely many solutions, is how we conclude with the given problem. So my learning outcome is a linear equation in two variables x and y has infinitely many solutions. The learning outcome of a linear equation in two variables x and y, it has the endless solutions, infinitely many pairs of x and y, as seen with the example problem, unlike the linear equation in one variable which has a unique solution. So we finally conclude a linear equation in one variable has a unique solution, and a linear equation in two variables has infinitely many solutions, cannot be unique. Now that we have seen the solution of a linear equation in two variables x and y, which has infinitely many solutions, unlike the linear equation in one variable which has a unique solution, let's enter into identifying the comparison between a linear equation in one variable and that of two variables, as we can do the comparison through conversion. So let's see how we can convert a linear equation in one variable into the two variable form just by using some simple mathematical process. Linear equation in one variable expressed as two variable form. Linear equation in one variable expressed as two variable form. So let's see how we can express in two variable form. So clearly we see that a linear equation in one variable p of x can be expressed in the form ax plus b. So here I write this as p of x as a times of x plus 0 times of y plus b, because when 0 is added to a term it doesn't affect. So I write this in the form ax plus 0y plus b, and hence I get this to be ax with two variables x and y, which is in this form. But this does not satisfy the condition for a and b not equal to 0, because the condition for a quadratic equation is ax plus by plus c equal to 0 with this and this. So this must be a linear equation in two variables x and y. Though this can be converted into the two variable form, cannot be a linear equation in two variables x and y, because it does not satisfy this condition. If a and b are 0, the x and y terms vanish, and hence it cannot be a linear equation in two variables x and y. Say for example, I have p of x is 3. I can write this as 0x plus 0y plus 3, because 0 when added to 3 doesn't affect the value. But since this is with two variables x and y, cannot be a linear equation in two variables, because this is not satisfying the condition a and b not equal to 0. The rules for a linear equation and its respective conditions. Condition 1 and condition 2. Now that we have discussed about a linear equation in one variable and two variables and its respective solutions and the conditions and limitations involved with the linear equations, now let's try to do some example problems to understand the concept more better. This topic is about identifying the coefficients of the linear polynomial or the linear equation. For example, I have the topic about identifying the coefficients of a linear polynomial. So let's see how we can identify the coefficients of the linear equation. For example, we have discussed in the previous sessions that a linear equation can be expressed in general form as ax plus by plus c equal to 0, with two rules. The rule 1 saying that a, b, c must belong to real numbers, and the rule 2 which says that both a and b are non-zero. So with these rules, this linear equation is about identifying the coordinates. So when I want to find the coordinate a, I clearly identify the coordinate a to be the coefficient of x. So for a given problem, if I need to identify the value of a, I pick the coefficient of x and that acts as the value a. B, the next coefficient being b, is clearly understood to be the coefficient of y. Therefore, in order that I identify the value of b in the given problem, I pick the coefficient of y and then that forms the value of b. Finally, it's about finding the constant c. So when I would like to find the value of c, I pick the constant value in the given polynomial or in the given equation, and that acts as the value c. is how we identify A, B and C. So the formula for finding A is coefficient of x, and the formula for finding B is coefficient of y, and the formula for finding C is constant. A, B, C are the constants of the given polynomial or the given linear equation, to be identified through the respective formulae definitions. Let's see an example problem to identify the coefficients in the given linear equation. Now here I have a question which says root 2y minus 4 is equal to minus 3/2x. Now here I have an equation which is given in an unsimplified form. So let's see how we can find the coefficients A, B and C for this given linear equation. So initially, for expressing this into the general form ax plus by plus c equal to 0, the first thing is about bringing all the coordinates to the left and equating to 0. So let's see how we can bring all the coordinates to the left. As I understand, this can be simplified by taking this minus 3/2x to the left, because I want only 0 out in the right hand side. So minus 3/2 when brought here reduces to less 3/2x equal to 0. Now keeping in mind the general linear equation being ax plus by plus c equal to 0, I try to express the given problem into ax plus by plus c form. So let's see how I can express this into this form. So initially I need to have the x term, the y term and the constant, and then the 0. So let's go with the same rule. An x term 3/2x, then the y term root 2y, and then the constant equal to 0 is how we express into the general form ax plus by plus c equal to 0 in the general form. Now let's see what is a, b and c values in the given equation. As we have seen in the previous session that a is coefficient of x, therefore I clearly see that the coefficient of x here is 3/2, or written in the form 1.5 in the decimal representation. So my a is 1.5 because it is the coefficient of x. Similarly, my b is coefficient of y, which is clearly root 2, is what we get for the value of b. And my c is clearly the constant, including the sign. Do not forget to put the sign for a, b or c for the respective coefficients. Coefficients add up along with their sign, positive or negative, as given. And c is the constant, which is minus 4. Therefore, a is this, b is this, and c is this. And finally, I get my a, which is 1.5, b, which is root 2, and c, which is minus 4, is how I understand the identifying of the coefficients in the linear polynomial in two variables x and y. A is coefficient of x, 1.5, b is coefficient of y, root 2, and c is constant, minus 4. But it's very important to note that this formula is not applied directly in the unsimplified form. The rule is about converting the given linear equation into the standard form ax plus by plus c equal to 0, and then pick the values of a, b and C using the formulae as learnt. A, B, C can be found using the process. Now let's see the linear equation applied in real life. Where do we apply this linear equation concept as learnt in the class session into the outer world? Real life applications of linear equations is the topic of the session. So let's take an example problem of real life situation into understanding the concept of linear equations more better. For example, I connect this problem with the age of a person. Say, a family has father, mother and son, and let's see how this can be connected to the linear equations. So let's say the father's age (20 years more than son). So let's say the father's age is 20 years more than son and mother's age and son's age is 12 years less than 6 years less than, or let me take 10 years less than mother's age. So here I have the condition in the family. There's a father, mother and son, where father's age is 12 years more than son's age and son's age is 10 years less than the mother's age. So let's see how we can connect this with linear equations. So when we want to connect such type of real life situations into the linear equations, we try to take the given conditions in the form of x and y. Situation 1 taken with x variable and situation 2 taken with y variable. So here it's being about the age of either father, mother or son. Here comes the question on representing age of mother as x. So let me represent the age of mother to be x years and age of father to be y and age of son to be z. So father's age I represent by y, mother's age by x and son's age by the variable z. So let's see how we can connect this. Now it clearly says that son's age is 10 years less than mother's age. Is how I connect between son's age and mother's age. So son's age is clearly said to be 10 years less than mother's age, and therefore I have my son's age, which is z, is x minus 10. Is how I connect one equation in two variables x and y. Secondly, I have father's age, which is 20 years more than son's age, which is z. So let's see how we can connect into two variables x and y. So father's age denoted by y is 20 plus son's age, which is z, is how I connect. And then I get this to be y equals 20 plus z. So I have two linear equations and two variables x and y. Here the variables being x and z, the variables y and z. So this is a linear equation in two variables x and z as obtained through the son's age and mother's age as a real life situation. And here I obtain a linear equation in two variables y and z as a real life situation connected with father's age and son's age. Now, how do I connect the variables x and y? How do I connect the mother's age and father's age? How do I know the comparison between mother's and father's age, which is not given in this? We can do that using the linear equation concept in real life. So let's see how. So as we know the relation between mother and son's age and the relation between father and son's age, now is the question on the relation between father and mother's age, indirectly utilizing these two equations. So let's see how we can do that. Taking the second equation, which connects father and son's age, y equals 20 plus z, I have my z, which is x minus 10. So in place of z, I substitute the value x minus 10. Because I have my z, I simply substitute the value in the equation. So I get this to be 20 plus x minus 10. So z is x minus 10. Therefore, I get this to be 20 plus x minus 10, which on connecting gives me y equals 20 minus 10, which is 10 plus x. That implies y is x plus 10. So what do I understand from this? I clearly make a comparison between father's and mother's age, that the father's age, which is denoted by y, is connected with the mother's age, which is denoted by x plus 10. So I can make a comparison here that the mother is 10 years shorter than the father, or father is 10 years older than the mother, is how we connect through the linear equation. So therefore, with the equation x and y, I make a relation that implies father is 10 years older than mother. So father is 10 years older than mother. A very long gap, 10 years of difference between mother and father, connected with real life situation. Now that we have discussed about linear equations in two variables x and y with its solution concept and identifying the coefficients and the possible number of solutions for that linear equation in two variables x and y and its connection with real life situations, now comes the concept of understanding the same linear equation in graphical concept. As we have discussed about the Cartesian plane and the representation of points and the rules in the Cartesian plane, let's try to connect the linear equation with the graphical understanding. So the topic of the session is about graphical understanding of a linear equation. Graphical understanding of a linear equation. So graphical understanding of a linear equation in x and y. What is a linear equation in the graph in the xy coordinate system? How does it look, or what is its shape, is what we're going to discuss in brief in the session. For example, I take the general linear equation Pxy denoted by ax plus by plus c equal to 0 with the condition a, b, c, the coefficients being all real numbers, and a and b both not equal to 0, is how we define the linear equation in general form. So for this, how does it look in the graph is the biggest question. So when we have each of x belonging to the real numbers and each of y equally belonging to the real numbers, I see that there are infinitely many solutions, and let's see how the shape of this linear equation looks in the graph xy coordinate system. So when I draw the x and y axis with the origin, this linear equation, as it is called linear, is nothing but derived with it looks like a line, a straight line. So linear equation has its name derived from line, and hence it looks like a straight line. So any line with just randomly passing through such a line is represented by ax plus by plus c equal to 0. So a linear equation in variables x and y in the xy coordinate system is a straight line. So a linear equation graphically is a straight line. Linear equation in a graph is a straight line which I draw with a ruler, is how I understand the graphical concept of a linear equation. Now let's take an example problem to understand the graphical concept of a linear equation more better. Let's see with an example problem considered. For example, I have an equation (4x plus 2y minus 8 equal to 0) is a linear equation. So let me take this example problem to understand this equation in the graphical form. A linear equation denoted generally by L can be written as 4x is equal to 0, is how normally I represent a linear equation. Now this, when connected with graph, the first thing I do is consider the table of values. So when a linear equation is given, I take the set of values as to graph the points. So once I plot the points, I join the points, and those points will define this equation. So let's see how we can identify the points need to be plotted. So for this, I take the variable x and the variable y in each of the rows. Now in this case, I take some fixed values this. So here we understand that when I take the fixed values of 0, 0 and 1, let's see how we can draw the line using these values. So let's see how the remaining values can be filled in the table using this equation. So as we clearly see that when x is 0, we need to find the respective y. It's about substituting the value of x in the equation and then finding the other variable y, is how we understand the concept. Therefore, when x is 0, I take x as 0, and then I get this to be 4x plus 2y minus 8 equal to 0 implies 4 times of 0 plus 2y minus 8 equal to 0, which on further simplification gives 0 plus 2y minus 8 equal to 0. And therefore, this simplifies to 2y minus 8 equal to 0. which when simplified further gives 2y equal to 8. That implies y is 8 by 2. That implies y is 4. Therefore, when x is 0, I have my y, which is 4, which gets filled in this box. Similarly, when my y is 0, what will be the value of x? Is how we understand. Therefore, when I take the value of y as 0, let's see what is the value of x. My y is 0. Therefore, substituting the value of y is 0, I get this to be 4x plus 2y minus 8 equal to 0 is what we get, which on further simplification gives 4x plus 0 minus 8 equal to 0, which on further simplification gives 4x minus 8 equal to 0, and 4x is 8. That implies x is 8 by 4, 4 to the right. That implies x is 2. Therefore, when y is 0, I have my x, which is 2. When y is 0, I get my x equal to 2, which I replace in the empty box. Finally, it's about filling the last. But we just need only 2 points to sketch the line. But we just take the third point for verification, so that when x is 1, let's see what the value of y is. X is 1. 2y minus 8 equals 0. So 4 plus 2y minus 8 equal to 0. 4 minus 8 is minus 8. Now that we have discussed about substituting the value of x here, I get this equation. Through this equation, when I simplify further, I get this to be 2y plus 4 minus 8, which is minus 4, equals 0. Therefore, I get this to be minus 4, and then I finally find the value of y from this equation. So minus 4 when I bring to the right is plus 4. When 2y equal to 4, I have 2 1s, 2 2s. That implies my y equals 2. Therefore, the value of y is equal to 2, and the value of x is equal to 2, and value of y equal to 4. Therefore, for x equal to 1, y is 2 is how it gets filled. To sketch the line, it is only essential for the 2 points in the first 2 columns, but this is not required. We only take this to just verify the line, but minimum only 2 points are required for sketching a line. Sketching through only 0, 4 and 2, 0. So let's see how a linear equation can be sketched on the real coordinate system, xy coordinate system of the Cartesian plane, to be followed with. Now that we have obtained the values of x and y respectively, I have a table of x and y values which form the coordinates. As we know that a coordinate is denoted by px, y is how we denote the coordinate. It is all x values which come in the first, which is abscissa, and all the y values which come in the ordinate. So let's see how each of the coordinates are identified. So the coordinates as identified through the first column is 0, 4. The value of x, which is 0, and the value of y, which is 4. And the coordinates which are identified through the second column are b, 2, 0. The value of x, which is 2, and the value of y, which is 0. Similarly, the coordinates as identified through the third column, which is c, which is 1, 2. The value of x, which is 1, and the value of y, which is 2, is how we identify the 3 set of coordinates picked from the table. Now let's see how we can plot these points on the Cartesian plane. This is the Cartesian plane. This is x-axis. This is y-axis. and then this is origin. Now let plot through the scale of 1 centimeter equal to 1 unit. Four, 5, and this is the scale, and then comes this. So once the scaling is done for both x and y axis with 1 centimeter equal to 1 unit in this case, let's see how the points can be plotted. Initially starting with A, which is 0, 4, my x coordinate is 0 and my y coordinate is 4, I get my first point, which is out here. Secondly, my second point, which is 2, 0, means 2 units to the right and no units out, no up and down movement in the y coordinate. Therefore, my B is 2, 0, which plots out here. Similarly, my C, which is 1 unit to the right and 2 units up. Therefore, my C moves 1 unit here up, and therefore I get this to be the third coordinate. Now, as we know that these two lines when joined through a ruler, I get a straight line. The third point is only for verification that it also passes, or else this would be a wrong equation or something is wrong with the values, is how we cross check through the verification process. So now that we got, it's about joining the line. Here is the line which I get for the given equation. Equal to 0. A line with the equation 4x plus 2y minus 8 equal to 0 is this line in the xy coordinate system. A linear equation is a straight line as given here in the coordinate system. Graphical understanding of a linear equation in x and y, a straight line, is how I understand through the learning outcome.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.